we have a line, right? We already know like a pretty good standard formula for a line, right? And the other standard thing we often find ourselves working with is a parabola. And so I've described to you how to get parabolas by transforming graphs, right? We can start with y equals x squared, and we can move it around, turn it over, stretch it out, shift it up, down, left, right. And that's a perfectly legit way of understanding it. But there's a much faster way, which since you guys get a formula sheet, I think it would be worth putting on the formula sheet just so you have like a go-to quick way to graph a parabola, right? And so here's the quick parabola guide, if you like. And so essentially this is the definition is y equals to some constant k plus a times x minus h squared is a parabola with vertex h comma k and axis of symmetry x equals to h. All right, and furthermore, there are two cases. One, if a is greater than 0, it opens up. So basically the picture is something like this. There's the vertex, right? And it opens up. It's like that, basically. That's the picture. That's what it looks like, give or take. Of course, you could put the vertex in any quadrant you like. It doesn't have to be in quadrant 1. It could be in quadrants 2, 3, 4, whatever, right? The vertex could be at the origin. In that case, we have something like y equals x squared, right? And then case 2, if a is less than 0, then it opens down, right? And so actually, these provide us kind of our principal examples of a function whose graph has a local minimum and has a local maximum. In fact, these are global minimums and global maximums for these functions because no matter how far you go away from the vertex, it's still the biggest or the smallest for a parabola, right? But that's kind of it. Like if you have this and you understand it and you can use it, you can graph parabolas pretty easily, right? For example, if I had y equals to 3x squared minus 4x plus 2, and I wanted to graph that, what I would do is factor out a 3. Right, factor out a 3. And then I do what? Something you guys need to learn in here, if you haven't already. Many of you have. Complete the square, right? So this is what x minus 2/3 quantity squared. And when I do that, I have to do what? I have to subtract 2/3 squared, which is 4/9. I'm going to rewrite that 2/3 in terms of ninths. How many ninths is 2/3? 6/9, isn't it? So I'm doing that so that I can think about the next step easier. 2/9, right? So we have 3 times x minus 2/3 squared plus 2/9. And okay, so to get back to my template, right? To get back to my my go-to formula here, this guy, I need to do what? I need to like distribute, right? What have I done? Something funny. They're smiling. I made no joke. Let's see here. 2/3. It's not always about you. Fine, fair enough. But what if it is? Let's see, 3 times x minus 2/3 squared, right? What is going on back there? All right. So at this point, you can read off what's the vertex of the parabola. What's that? But remember the minus here, right? So like we should have, if we think about y equals to f of x in this example, we should have f of h equals to k. So, I mean, wow, that's, whoa, what are the odds? 2/3, 2/3? Good night. Like, that was an accident. That was an accident. That's cool. That's, if you'd asked me, find a parabola whose vertex lies on the line y equals x at 2/3, 2/3, like, I would not have expected 3x squared minus 4x plus 2 is that. But apparently, there it is. Okay, so that's the and it does what? It opens where? Up, yeah. And if we want to get a sense of scale, what can you do? I usually use the Y-intercept to set the scale if I'm going to be careful. What's the Y-intercept here? Remark, to find Y-intercept for y equals f of x, plug in x equals to 0. This advice transcends this example. This is like, I have a 2, dose, yes, 2, which in my picture is somewhere like up here, maybe a little bit higher. So anyway, it's something like, I mean, I always regret my graphing choices, but it's something like that. And the axis of symmetry, of course, is like that. So if I did it right, it should open the same left and right of that axis of symmetry. So if you have this formula and you understand how to use it, you can make pretty quality graphs of parabolas with this little bit of algebra. And if the function's not so nasty, like 3x squared minus 4x plus 2, it's a lot faster, right?
Can you go over like vertical and horizontal, I guess, dilation?
Sure. So vertical means it like stretches. Let's see here. I need an example, don't I?
Like how to know which way it's going
Oh, I think that a given example probably could look at it as either. I mean, it kind of depends on the example, but there are examples where you could either look at it as a vertical stretch or a horizontal compression. Like you could go either way. Let's see here if I can give a quick example of that. So if we look at f of x equal to the square root of x, right, as our starting function, that looks like what? Let me put in some points. 0, 1, 2. When we get to 4, we're at 2, right? So here's the graph. Y equals the square root of x, right? So let's look at g of x equals to, 2 times the square root of x. That would be a vertical stretch. Like the natural interpretation would be that's twice f of x, right? So basically, we just take every point in the f of x graph and multiply by 2. So like 0 goes to 0. 1 times 2 is 2. 2 times 2 is 4, right? Almost off the chalkboard for me. So there's y equals 2 times the square root of x. But you see, we could also look at that as a compression, right? I mean, we could also, if we put the 2 inside the square root, how would that look? I mean, what's the algebra of that? This is equal to the square root of what? I guess I'll do it. This blue chalk is worthless. I'll have to do it in white. Square root of what? 2 squared, which is what, 4, times x. There's an algebra step you might have. I don't think I've done that algebra step yet this semester, have I? That's a new one, right? If you bring a number inside the square root, you have to square it. If you don't believe me, you can undo it, right? Square root of 4x is square root of 4 times the square root of x, which is 2 times the square root of x, right? So that's why I'm not wrong. But, okay, square root of 4x would be f of what? F of 4x, right? Which, according to our rule, is supposed to be what? A compression of what? Compression by a scale factor of 4, right? Compress y equals f of x by a factor of 4 horizontally. So how is that game played? I'll try to do that one in blue. We take a point on the original graph and we divide the x-coordinate by 4, and that gives us the corresponding point on the compressed graph. So like this point, 1, 1, in the compressed graph, it goes over to here, that point, which is 1/4 1.
So you only divide it by the x.
Right. Yeah, it smushes the graph that way.
So really you can just plug in points to kind of figure this out.
That is true. To stretch a graph out, we could, pick 3 or 4 points on the graph and study what happens when we multiply the y values by 2, right? Or you could, to compress, you could pick 3 or 4 points and study what happens to the x values as you, I don't know. I don't ever find myself doing that much, actually, but this one over here would be what? This point is, what was it, 4, 2? So that compresses over here to this point, 1, 2. So you can either look at y equals, 2 times the square root of x as multiplying the y equals square root of x graph by 2, or you can look at it as shrinking the square root of x graph by a factor of 4. There are other examples which you could look at. There are ones where there's not this kind of you could look at it either way sort of thing. Like if once there's shifts and stuff, it's not going to be so easy to see that. But listen, just to be clear, if graphing a parabola comes up on the next test, I'm not going to force you to do the transformations idea. If you want to just use the quick guide thing I just wrote down as a method to graph, that's fine. If you want to use your graphing calculator to graph, that's also fine. But, you know, anyway.
So you won't be looking for precision with the graphs on the test?
Well, I don't know. I mean,
Like the Y-intercept, you want to have that.
you know, if I just say make a quick sketch of the graph, then precision is not important. If I say, it depends on the wording of the question, right? If I say graph, be sure to include x-intercepts and y-intercepts. Or if I say graph carefully, then I'd be looking for some more detail, you know. And it's always the case that there's partial credit, and it's always the case that if you do a lot more detail than anybody else, if I look at that graph and it's just like pristine and beautiful and like, and it you know, it takes the rest of the graphs everyone else made out into the street and beats them down into a pulp, then I might give some bonus points, right? I mean, I do like to respect domination, but anyway, it depends on the instructions as usual. Yeah. Can I erase? Do you guys have questions about the mission that we should ask specifically?
Can you mark a difference question from?
Oh, sure. Let's see here. How about f of x? Which one did I give you in the mission? I've forgotten the formula I used in the mission.
F of A minus like that.
Oh, so I used the a plus h one? Okay. But what was the function I gave in the mission?
3x squared plus
3x squared plus
2.
Okay, so I'll do, how about 3x cubed minus x plus 1. Let's find difference quotient. This one's harder than your homework. I will soon regret assigning this to myself and simplify. I think that's essentially, what problem is this? Problem 25. This is problem 25-ish. All right, so we have to calculate f of a plus h minus f of a divided by h. So I start by writing that equals. Okay.
That's a good question. Does it matter which one's first? Because on here it says f of a minus f of a plus a.
I did that?
Yes.
Really? That's not right. Do it this way. That's a typo. I am so sorry about that. Sorry. If you've already done it the other way, you can just, at the very last step, say, I won't count off if you've already done it, but it should be this. I mean, this would give us the average rate of change from a to a plus h. All right? Anyway, so this would be what? 3a plus h cubed, right? Minus parentheses a plus h plus 1, all divided by h. And then minus, I'm going to use some square brackets here. I have 3a cubed minus a plus 1. Do you guys see anything that cancels right off? Without further ado, how about this one and that one? Because of the minus, so those cancel. And can you guys tell me what a plus h cubed is? I usually think about the Pascal's triangle, and that tells me this is a cubed plus 3a squared h plus 3ah squared plus h cubed. You're like, what? Now, if you're like, what? That's fine. Just remember you can multiply it out, and you should agree with me after you multiply it out. Now, your homework problem's easier than this, right? Because you just have to square a plus h. A plus h squared, you guys can do that. It's not a big deal. Is there anything, anything in common here that's going to cancel out again, I'll ask. I mean, when we multiply this through, right? See this, 3 times a cubed? So that gives me exactly the same term as this one. I can cancel those. That does not get rid of the 3, right? The 3 is still multiplying this, this, and this in the next step, right? So, also, how about, What's wrong with my current step? I did not distribute the negative, is correct. And so that last minus a is actually supposed to be a plus a, which is good news, because then what happens to the a's? They cancel. That's right. This is a minus minus, which is a plus. See that? So then, yeah, this guy and that guy is gone. As I was just saying, this one and this one is gone. So what do we got? 3 times 3 is 9, a squared h plus 9 ah squared plus 3 h cubed minus h, all divided by h. Can we simplify that? We've got a common h, right? What's that? 18? Oh, we can't add them together. These are apples and oranges, right? This is, careful, we can't add these together because like the pattern's not the same, right? This one's got an a squared, that one's got an a. That may not have been what you're saying, but somebody else in here is thinking it too, I'm sure. So factor out an h, right? H times what? 9a squared plus 9ah plus 3h squared minus 1, all divided by h, right? So I'm just factoring out, there's a common h squared, h cubed. So I'm left with an h from the h squared. I'm left with an h squared from the h cubed. The reason I do that is, of course, the h cancels, right? Reduces like this. And we're left with 9a squared plus 9ah plus 3h squared minus 1. And there you go. That's the simplified difference quotient here. That's the answer in this one, yeah. The homework problem is a little bit easier than that because it's just a square instead of a cube. But the answer should just be, something somewhat similar, I think. What was the homework problem?
3x squared plus 2.
3x squared plus what?
2.
Just plus 2?
And there's like one more.
One more of them. Yeah, this one should end up with like a, I think you should end up with like a 6a. and then plus stuff with h's, which I don't know off the top of my head, but 6a is part of the answer. I'm cheating with calculus, but anyway.
Where does the 3A cube go again on the second step?
This one?
Yes, on the end, that 3A cube.
So I'm saying this cancels against this guy over here.
Okay.
That's all I was saying. So then, you know, it's always a good idea to count. What's that? No? It's always a good idea to like count. So this one I had 1, 2, 3, 4. If I multiplied through, I have 4 terms here. 5, 6, 7, 8 total terms, right? And I'm saying these two canceled, right? And I'm saying that these two canceled, so that should leave us with 8 minus 4, which is 4 terms left over, and we've got 4 terms down here. It's just kind of just a quick check if I've missed something or not, you know? Would you like me to work a different but easier problem? That'd be helpful? No? What was the other one in the homework?
The different,
The function, yeah, the
x over x plus 1.
x over x plus 1.
Yes.
Let's see here. Something that would be, I could just do 3 over x minus 2. That might be kind of similar, but a little bit different. So f of a plus h minus f of a. So we're doing 3 over a plus h minus 2 minus 3 over a minus 2 divided by h. And your homework problem would be similar. It's just you'd have an a plus h and an a in the numerator from the evaluation of a plus h or a. But the basic algebra you need to do is very similar to this example. You need to make a common denominator in the numerator, right? So the next thing I would do is write the 1 over h out front, just to get it out of the way. And I would do 3, and I pull the 3 out too, because why not? You know, pull this 3 out. So 3 over h, and I'll rewrite what we're facing. 1 over a plus h minus 2 minus 1 over a minus 2. And we need to make a common denominator. How do you do it? We basically cross multiply, right? So we do a minus 2 minus parentheses a plus h minus 2 divided by a plus h minus 2 times a minus 2. That's the algebra you want to do. What happens? No, because they have to be common to everything. I mean, I can't cancel that with that because I would need it to be multiplying everything on the top in order to factor it out and cancel it. Like here, for example, if I have a plus b over a plus c, I can't cancel a here. Like that's not an allowed algebra step. I would have to have a times like, you know, b plus b prime or something over a plus, well, I still couldn't do it. I still couldn't cancel this and that because I need to be able to factor out a from both the numerator and the denominator in order to make the cancellation. distribute the negative. Okay, yeah, we could do that, sure. 3 over h. I mean, if there's any criticism of my current algebra, it's that I haven't done that in the last example. I would advise against multiplying out the denominator. Just leave that alone. Same goes for your example in the homework. Just leave the denominator alone. Like, don't try to multiply it out. It doesn't help. Cancel, yeah. So there's a 2 and a minus 2, and a and a minus a. We're just left with minus h. But minus h divided by h is what? Negative 1. And so what we got is minus 3 divided by a plus h minus 2 over a minus 2. And that's as far as it goes. I mean, you could multiply out the denominator if you'd like, but that's it. For those of you who have had calculus in high school, the extra step we made there is like we took the limit as h goes to 0 of the difference quotient. Right? And when you do that, this simplifies to minus 3 over a minus 2 squared, which you might recognize as f prime of 2, or f prime of a, rather, because the derivative of 3 over x minus 2 squared is minus 3 over x minus 2 squared. Some of you have done that in high school, I'm sure, like 1 or 2. If you haven't, that is fine, but that's part of the reason that these examples are included in pre-calculus. It's a foreshadowing so that when you get to these limits at the start of next semester, and next semester in calculus, after you've taken the trigonometry part of this course, and then the other semester, then you're sort of already have some experience. It's not your first rodeo, so to speak, which is not just an idle expression at this campus. We do have a rodeo attached to this school, I found out last week. That's my first rodeo excuse for a student. It's like, I can't be a class, I'm going to set up the rodeo. It's like, what? So of course I had questions, but anyway. Can I erase this offending calculus? How many of you, this is the end of the road, this is your last math class? So you can set this comment to 0. All right, yeah.
Quick question. When we use Pascal's triangle, I know how to use it, but how, when can you use it again?
Just anytime we have, basically, anytime you're looking at something like a plus b to the n power, then it gives you the coefficients on that. And what you do is you like a to the n, and then the next one is always n, a to the n minus 1b. And eventually you get to n, a, b to the n minus 1 plus b to the n. And like that's always the pattern. There's always like a, if I went further, there's always an n on the outside of this thing. Actually, you can only see n so far. This one. See, there's always like, this is for the 4th power, the 5th power, there's a 5 out here. There's these more exciting 10, like that. So there's always n corresponding to this term and that term. And then what happens in the middle is more interesting once you get past like power, the 4th power. If you don't know Pascal's triangle, does it matter in here? Probably not. Right? I mean, in principle, what could you have done with that previous example? You could just do what? Just multiply it out, right? If you have a cube, you just multiply it again, and you got it. It's just tedious. Let's talk about graphs. I think people need more work with graphs. I just graded intermediate algebra this weekend, and I'm going to assume that you guys also have a deficiency in interpreting graphs, right? And what I mean by that is, if I give you a graph, there's all kinds of information in it. Do you know how to use that information, right? Like, see here, suppose this is y equals f of x, and I'll make g of x very boring down here, right? So let's suppose that, let me make it up here actually, y equals g of x. So I'll make g of x the constant function, and let's make it equal to -1. All right. And let's see here. All right. Here's an example. We can calculate the value of, well, let's do something simple. What would f plus g of 6 be equal to? Well, I'll do the easy step. That's f of 6 plus g of 6, right? So then my question is, what is f of 6 and what is g of 6 equal to? I told you g is a constant function, right? So g of 6 is easy. That's just -1. What's f of 6 equal to? 5. Very good. How did you know that? That point right there, right? So generically speaking, every point in the graph has the form what? X comma f of x, right? So if you have a point in the graph of f, you can read the point as x comma f of x, whatever that could be. In particular, this has to be what? This has to be 6 comma f of 6. And so that's how you knew that f of 6 was 5, right? That's equal to 4 then, right? What if I was to ask what is f of f times g of 6? What would that be equal to? Yeah, 5, that would be f of 6 times g of 6. And I heard a -5, and I will accept that answer. Let's see here. Very good. Could we do something more interesting? How about, would it make sense to ask what is f composed with g? What is f composed with g of 6? How does that work? What's the definition of composition? We do what? F of g of 6, right? By definition, that's f of g of 6. What's g of 6? G of 6 was -1, right? What's f of -1? 0, right? See, you guys got this. Could I calculate g composed with f of something? Can you give me a value which we can actually do? How about g of f of, 6. How about 6, right? That would be g of f of 6. What's f of 6? I heard a 5, yeah. What's g of 5? -1, right? So, is there a problem like this in your homework? There is not, right? There's a problem in your homework where you add two functions given the graph. There's a problem where I tell you the values of the function and ask you to find like f plus g, f times g, f minus g, f composed with g of something, g composed with f of something, right? But another way you could present that problem is to give you the information about the graph, about the functions rather, graphically, right? This is another version of that problem. Do you guys have any questions about the inverse function stuff? Who's good on that? All right, well, I think that's a good place to stop for today then. Thanks, guys.